And unless anyone else has loaded a presentation in the meantime, the next one is the final presentation for this flash session. So the next presentation is on scaling up river water fed managed aquifer recharge in the deeply anoxic Macquarie aquifer in Gisborne, back in New Zealand. And the presenter is Rat? Is Rat? Rat? Niels. Okay, Niels Hartog. Okay, thank you very much. Over to you.
Thank you. All right, so my name is Niels Hartog. I also don't know exactly how to pronounce Macquarie, but I'm trying to take you in a flash to the other side of the world, where trials are being done to realize a MAR system in a highly anoxic gravel aquifer. I'm talking while I'm waiting for my slides to come up. It's a very intense horticultural area, as you can see here. Citrus, oranges, corn, high water demand. It's a temperate climate. Well, demand has been increasing over the years. And there's about 1,000 millimeters of rainfall per year. As you can see, it's highly variable. And over the years, you see that the average trend, the variability is still in place, but on average, there's a decline in the groundwater levels. And economically, this region is growing, putting more pressures on the availability of water for horticultural. And also at the same time, it's been noticed that salinization from the ocean starts to occur on the ocean side. So it's time to come in action before you get conditions like in the Netherlands where you have completely salinized aquifers. Principally, this is a project done by Golder Consultants in New Zealand. I'm from the Netherlands, KWR, and specifically for the chemical aspects involved with the project, which I will be talking about a little later. This is just a hydrogeological sketch of the area. Here you see the plains, and it's being recharged, the Macquarie aquifer, from the mountain ranges, and it's about 50 meters below surface level. And this aquifer is interesting because its thickness is 1 to 15 meters, so maximum thickness of 15 meters, 1.5. But it's a gravel aquifer. It's a coarse gravel aquifer. So it is possible to do infiltration there. That's what was tested, and that's what we've been working on since. It's also highly anoxic. That is another typical combination for a gravel aquifer, at least in my part of the world. So it contains a lot of methane, high CO2 pressures as well. So there was a trial, about 70,000 cubic meters were infiltrated, 60 days, and an average infiltration rate of 15 liters per second. So this is what it looks like in an overview. Water's been taken in from the river. This is the intake gallery, and then it's transported to the infiltration well site, where there's injection and the filter set up. And then around, or particularly downstream, because the regional groundwater is coming from the western side, monitoring wells in the vicinity of that infiltration well. And one of the first things we looked at is to see how that mixing occurred between the river water that's being infiltrated with the native water. And as I mentioned, salinization is an issue. It's not that the salinity in the native aquifer is caused by recent seawater salinization, but it's brackish in its own original composition. And of course, the river water is very fresh, and that's being infiltrated in the winter periods. And here's chloride versus bromide, both conservative tracers. And as you can see, this is a very nice correlation to work with. So the surface water infiltrated locations are on the left-hand side, low chloride, low bromide, while on the right-hand side, right-hand top, is what the native groundwater composition looks like. So this gives us a very good handle on the fraction of infiltrated surface water in a particular sample. If you then go on, if you continue to use chloride as the conservative tracer, and you look at sodium, then those of you familiar with freshening and salinization of aquifers will notice that you have an increase in the sodium concentrations because calcium is displacing the sodium from the cation exchangers. So this is in line with what we're expecting, this increase in sodium to occur. Then looking a little bit at the redox, because I mentioned that it's methane containing. I'm not saying methanogenesis is happening there because it's a gravel aquifer, that's something to be found out. But what we did notice is that nitrate disappears very fast to below detection limit within the first few meters from the infiltration. So denitrification is for certain going on. Sulfate reduction is also taking place, but not to the same extent. And of course, when you're injecting oxic water in an anoxic aquifer, there's always the thought of possible pyrite oxidation to occur. Now, there's a whole bunch of chemistry data that I can't show you, but arsenic is, of course, a prime parameter to look at. And what you see is actually that arsenic concentrations found are highest in the native groundwater. And you don't see in any of the surface water impacted samples an increase in arsenic. So from this point of view, an improvement of the water quality. And the next steps are to look into more parameters and also the organic micropollutants that are infiltrated into the system. All right, with that, I'll come to the conclusion. Thank you.
Great. Thank you very much, Niels. And thank you to all the presenters for keeping time. And that gives us just a couple of minutes to take one or two questions, if anybody has any. Please.
I will ask a question to the last speaker. How did this soil filter nitrogen? I didn't think that was possible.
It is possible. That's been shown in many cases. It depends on the redox condition of the aquifer. So if there's organic material associated with the sediments, there's wood fragments found in this gravel aquifer, then that gives potential to take out these oxidants. Yeah.
Great. Thanks, Niels. Any more questions? Yeah, there's one up the back there, and then you next. Up the back there, please. Do we have the microphone? Ah. Okay, scream loud.
Good question. Of course, we looked at that, and it is of current ocean water. About 300. Yep.
Everybody heard the question and answer, okay? All right, thanks. And there was a question down the front here, please. Any more?
Niels, could it be that the nitrate is denitrified by the methane itself? There could be gas pockets remaining in the aquifer. They could do the job.
Interesting, Peter. Yes. For the dissolved methane, it's present it's 50 meters below ground surface, so you have a high hydrostatic pressure, which means with the concentration of methane we're expecting all the methane to be dissolved. And then when you start injecting surface water, you're actually also displacing that native groundwater. So you can have some reactions on the fringe of the volume you're injecting with the native groundwater surrounding it. But the primary process, we think, is the interaction with the organic matter in the sediment as the nitrate-containing water passes through.
Okay. That shows the benefit of speaking last. You get all the questions. All right, thanks. Well, that brings us to an end of this session. I'd like you to join me in thanking all the speakers both before and after lunch. Thank you all very much for keeping time, doing such a good job. I'd like to thank all the participants. Again, the number of people here in the MAR and IWRM sessions is an indicator of how important it is that we consider MAR in the context of broader objectives. And I guess that's why so many people were here. That brings this session to a conclusion. We'll hand over to Professor Zheng for session 3, which is about new regional case studies. So once again, thanks very much for your participation.